All right, let's look at our last most complicated scenario. So, this is formula to name with metals with multiple charges. Take a moment to just read through the steps, or I should say the criteria, in order to get there, and then we can look at some examples. So, these examples here. We first need to know what is the charge of chromium. Well, the charge of this polyatomic ion is 1 minus. And there's 3 of them, so its total is 3 minus. Because ionic compounds need to have equal and opposite charge, that means chromium needs to be 3 plus in order to balance out the 3 minus by these 3 polyatomic ions. Now we know that, the rest is a little simpler. So chromium and the charge, 3, because that's what we've discovered. And this one is perchlorate. You would just copy this back from the back of the reference sheet, because that's what it is. It's named perchlorate. Here we've got SO3. We need to use the negative ion, so that's 2 minus. I have 1 zirconium, so that means it has to be 2 plus. So, name, zirconium. Its charge is 2, so we write Roman numerals 2. And then SO3, that's sulfite. Not to be confused with SO4, that's sulfate, so sulfite. Over here, sulfur. It has a charge of 2 minus, right? But there's a total of 3 of them, so that's a total of 6 minus in charge. Now, the molybdenum, that's what MO stands for, has to have a total charge of 6 plus. But I see there's 2 of them. So that means each molybdenum has a charge of 3. So moly, B, D, it's a weird one, I wrote it down, EN, UM. And remember, the Roman numerals tells us the charge of each ion, so 6 divided by 2 is 3. And then sulfur becomes sulfide. For all of our practice we've been doing, elements always end in IDE. Lastly, silicon. This thing's getting irritated here. Silicon has a 4 minus charge. Need to write it over here. That means manganese needs to have a 4 plus charge. But there are 2 of them. So 4 divided by 2 is 2. So manganese two, because that's the charge of each manganese. And this one's kind of funny because it's silicon. That becomes silicide. All right, these are the most complicated, but determining the charge of the ion is going to be critical when we do balancing chemical equations. See, that wasn't so hard. Negative. Very negative. Coming down to our joke. Why did the chemist sole and heel his shoes with silicone rubber? It was to reduce his carbon footprint. Answer this final question and come in with any kind of questions you got. Sorry it took a long time. It's all about writing and giving you enough examples so you can be successful. See you soon.